This conference will now be recorded.
Thank you all for taking the time to listen to this presentation from the Specialty Products Group. My name is Scott Bergsbakken. I'm the president of the Specialty Products Group, and I'm accompanied by our soil specialist, Jay Lemansky.
Hey, Scott. Really thrilled to join you in this presentation today.
We're going to discuss the benefits of using VaporLock SCS120 and VaporLock 555 to solve your frost road issues, your frost boil issues, and your general stabilization issues. To date, starting in 1935, soil stabilization typically relied on 6% cement tilled into the soil utilizing a reclaimer. Then 4 inches of 1 3/4 inch rock was applied to the top. Eventually, the water got on there, got through it, went down, and eroded that cement application underneath the soil, and it fell apart, and then you had to reapply new rock. So we have a different approach. We have been manufacturing VaporLock as a concrete admixture for decades. It's used to waterproof concrete. It reacts to cement and makes the system waterproof, as you can see here. So if we could take the cement under the soil and give it the same properties, which we've done, you'd have a very stable system. This shows the chemistry of VaporLock and how it works with the cement. That's water he just put in there, Portland cement, and the next one will be water. We're making a control sample there. Here you have water, Portland cement, and VaporLock. And you'll see how that reacts and makes the cement waterproof, which is what's going to take place underneath your soil when you till it in and add VaporLock into the water truck to go into it.
Yeah, Scott, this demonstration, so no one is alarmed, it's 600 times of an overdose, whatever we would put in the back of a concrete truck. This is just overdose to speed up and show you what's actually happening here. We're converting calcium hydroxide back into CSH, or calcium silicate hydrate gel, which is the building block of concrete. We are completely eliminating the bleed channels.
Right. And this is the same chemistry that's employed by fly ash and slag in concrete, but it all reacts with the cement, react with the cement in the soil in the same way.
So the first product that we bring to bear for stabilizing soil bases is our VaporLock SCS120. We've taken the same technology from what we do with concrete, and we brought it to the stabilization of the base. Lots of huge benefits by utilizing this product, not to mention that we're virtually eliminating the leaching of cement into the groundwater. It's NSF 61 approved and VOC free. And this also represents a 33% reduction in the cementitious content spread on the surface.
Which is just an amazing thing. We're going to explore what that really means mathematically. Here we have a little demonstration conducted by our soil specialist. Why don't you tell us about it, Jay?
Yeah, Scott, this video shows clay-based soil being completely oversaturated into a liquefied state, then completely stabilized into a workable surface. This is to show you how quickly our products work on any type of soil. This is a speeded up version, much like we just saw with our concrete admixtures. If you'd like, I can provide you with a video where we have measured out the actual volumes of soil, cement, water, and our VaporLock SCS120. Cement modified soil got started back in 1935 and has remained relatively unchanged in 85 years. Even today, the process remains the same. You have a geotechnical company drill samples around your site and determine its contents, including clay, sand, illuminate, nickel, and its PI. That's the plastic index. They will then make a recommendation on the percentage of the weight of the yard of each test drill to make for the cementitious content to be spread on the surface of the soil, to be ground into the soil with the reclaimer. Typically, that number is 6% of the weight of that yard. We utilize the same installation process for the soil base, But what we have done is reduce the cementitious content spread on the surface by 33%. We add our VOC-free VaporLock SCS120 into the water truck that feeds the reclaimer. This completely waterproofs the base, any road or project site.
And it's really a nice system because it's completely invisible to the soil contractor. And it brings all positivity to it. We're reducing the cement, putting in some VaporLock, increasing the compressive strength as shown by our extensive proctors, and increasing the tensile strength.
Another great factor here is the difference in the cost of 2% of the Portland or lime kiln dust basically is the cost of what our SCS 120 would cost. So you're waterproofing your base at seriously no extra charge over your standard 6% stabilization.
Amazing results achieved economically. Not only economically, but sustainably. That reduction in the Portland cement, saving 275 million BTUs for every acre.
Scott, that's the equivalent of 13.2 tons of coal saved in an acre of material. Now, instead of sitting in your trailer watching critical path days fly off the calendar because your entire job is in the mud, we can put you up and running from the start of your job.
Now, here's a project that was done in Tennessee, I believe, where they used 6% soil in the traditional methodologies, but they were very concerned about one area that they utilized our program in, this area pictured here. So they put SCS120, used only 4% cement in there, and look at the difference in results. This was all stabilized at the same time, and all these pictures were taken at the same time. They ended up having to redo the other section, but the section that we did where the portable concrete batch plant was located, you can see there's not even a tire rut.
Yeah, Scott, the first pictures are straight 6% cement modified soil, and then they have to put down 4 inches of rock or 6 inches of rock, costing anywhere from $250,000 to $350,000 per mile. Given enough rain, the cement will fail, and then you're talking about additional applications of that soil, which completely can break the budget on a job. Again, as you said, this is the lowest elevation, and all we did was waterproof the base. 60,000-pound ready-mix trucks drove all over that without a tire track. So the second product we bring to bear in our stabilization system is the VaporLock 555. You can consider this product like a liquid tarp. VaporLock 555 is a high-performance, rapidly renewable, organic resource that stabilizes granular particulates of all types. It can waterproof stockpiles, conceal mine tailings, shoulder stabilization, and erosion control. Also, recycled asphalt and recycled concrete can be tied back together with our VaporLock 555.
Here's an example of VaporLock 555 that we applied to sand. I did this personally. We put that sand in place and it flowed through my hands to go into the pile. We kind of molded it up with our hands, applied VaporLock 555, 1 part VaporLock 555, 3 parts water, sprayed it on there, 2 light coats, came back the next day and dumped some water on it. And this is the same effect that you will get in your soil stabilization and in your frost boils.
You know what's great about this also, Scott, is how much we reduce carbon footprints in multiple areas. Just by utilizing the 555, we're completely reducing airborne particulates around job sites, on secondary roads, you name it, helping the environment.
And by putting VaporLock SCS120 and 555 together into one package that costs less than the current traditional methods, you're really gaining a lot. It's environmentally friendly, completely VOC free. Like we said earlier, that 33% reduction of cement or LKD results in a savings of 275 million BTUs expended on the job. What a fantastic story that is. And one of the big items here is the fact that the whole program is freeze-thaw resistant. it really holds back the soil to a large extent from having issues. So we took this freeze-thaw application and went and solved the frost boil.
Yeah, Scott, I was just going to echo that same sentiment. The freeze-thaw resistance is how we solve the frost boil problem that we're getting ready to take a look at.
In Buchanan County, Iowa, they have a road called Frost Road, and they have frost boils on the Frost Road show up every spring. So they utilized our program to eliminate that, and we consider this to be one of the penultimate challenges in the soil stabilization world. This is what that road looked like every spring. It's a real problem. There's a lot of agricultural activity taking place on this road. Big hog farms, feed being brought to them, hogs being trucked out. And this is what a frost boil is.
Yeah, Scott, frost boils are created when frost or water in the gravel roadway melts in the spring, but it can't drain away because of the frozen ground below it. The soggy roadbed eventually heaves, softens, and fails, leaving ruts and maintenance headaches for county road crews, not to mention the liability to the county and dangerous driving conditions. When you look at this chart, you will see the arrow pointing up frost heave, frozen zone, and then below that are the ice lenses. Think of these ice lenses as a tectonic plates. When they're stacking on top of each other, they're being forced to the surface. In the spring, the rain softens the surface of the upper crust, and then they force through, and nothing can stop it. Well, nothing but Lock SCS120.
So here's our doubled up system. And doubled up, increasing the strength is measured by proctors, increasing the tensile strength, and it's less expensive. On a roadway, we're saving about $50,000 a mile.
And that's also around $30,000 to $50,000 per kilometer.
So it's the normal system, 12 inches of soil-based stabilization, just like it's done right now, except we're going to use less cement. We're going to put in a little bit of SCS120, 1 gallon of SCS120 for 30 gallons of water, so a 1 to 30 ratio. We'll mix that in, put it in with the reclaimer. Then when they're done with that, they'll put 2 inches of stone on top of it, apply 555 to it, compact it, and we're going to show you some results here, what this system can bring to you. Not that, not that. Here they are putting it in there. 4% going into the cement going into the road. And in front of that, they have a water truck, and here they are adding VaporLock SCS120 into the water truck. That's going to get pumped into the soil through the reclaimer while they're tilling it in. 2 inches of 3/4 crusher run on top of it.
And now we're going to go ahead and liberally apply 2 coats of our 555, which is broken down 3 to 1, 3 gallons of water, 1 gallon of another environmentally friendly product that we're saturating the granular particulates. Now you can hear complete saturation of this road, and that's how wet we want it to be. It's being rejected by the soil because it's completely waterproofing it. That's what we want to see.
And right here, you can see where they stopped. And that line of demarcation is going to come up later on. Well, it's actually the other end where we're filming it, but it's a similar line of demarcation.
So now we're going to run a hydrostatic roller over it to marry all of these items together. The typical means and methods for these secondary roads is 4 inches of 1 3/4. And they believe that that will keep on the road and won't be knocked off by typical traffic. With this system, we're down to the 2 inches of 3/4 crusher that we discussed. And now this hydrostatic roller is marrying the waterproof base to the crusher, and then it's completely coated again with the 555 to where it's waterproof on the top. Again, on the left, you can see here where there's been 1 pass of the hydrostatic roller. And people, when you stand on these roads and see this, it looks like someone took glass marbles and laser screeded them into the surface. Now what we've got is a maintainable, dust-proof, waterproof road that will last until you want to remove it. All it may require is a mere fog coat every 6 months. Scott, tell us about this.
The waterproofing is just amazing, and it's really the key to the success of this program for the frost boil program and general stabilization. And here it is. We went back 2 years later. Like we said, they conducted no maintenance on this road. It's been through 2 winters. And we're going to dump some water on this in similar fashion as we did. This is 2 years after the fact. And look at that water just bead right off.
Yeah, Scott, you know, if this was being poured on just a standard country road, gravel road anywhere, it would be absorbed right through and not be running or shedding off like this is doing. It was extremely impressive to sit there and see that happen. That was a full gallon of
Yeah,
water.
look at that gathered. Look at it gathering up at the bottom into a puddle and not absorbing into the substrate.
Unbelievable. That's how you solve frost boil, Scott.
And additionally, while we are stabilizing this soil, solving the frost boil issue, we are also making this dust proof. Here we are driving from a treated section of road onto an untreated section, and you'll see the second they make that change right there. So this is 2 years after the fact. We went back and drove down the road again. We had a little light dust on the treated section, but they'd had no maintenance coats. The dust was carried on through traveling. But you'll see a distinct difference when they go from the untreated to the treated, even 2 years after the fact, right there.
So here we are 2 years later. It's not the prettiest road, but by gosh, it is exactly what it is advertised. There are no frost boils in this road. So unbelievably, we did stop Mother Nature with this system. And again, as Scott mentioned, 0 maintenance, 2 full winters of snow with a road grader removing it. If you look on the side of the road in these pictures, you're seeing actual snow there. And what you're not seeing is a huge amount of our crusher run that's been pushed to the side. It's all still 100% completely embedded in that road.
It's amazing. This is a close-up of it, and it looks like concrete. If you were to stand on that, jump up and down on it, you'd think, wow, that's concrete. And it's 2 years after the fact.
Again, here's where we are. No gravel, solid, no maintenance. If you want to completely keep the dust down, you just put a fog coat every 6 months. While this is an excellent example of a secondary road out in the counties, think about building a hospital next to a hospital or building a school and having these kind of work roads around those areas. We can dust proof and waterproof it, which we're removing the airborne particulates and making a safer work area for the workmen and for the clientele around it.
And in this case, being that it's Frost Road and the goal was to solve the frost boil issue, immediately adjacent to where we treated, they had frost boils. You can see them pictured here. In the area that we treated, they had none, and they had a recurring history of frost boils in that area.
Scott, you think you could just take a bulldozer and flatten that off, and that would take care of it for the summer, but that's not the case. Once this occurs, it continues to push up and out as long as there's spring rains, and you know it's going to be saturated with rain until the next fall.
Yeah, they're pretty pleased with it there, and they'll be treating all their county roads that way in the future, I'm sure. And obviously, this system has a tremendous amount of uses beyond just solving the frost boil issue. You know, railroad truck bases, wind farms for the dust proofing, on and on the list goes. Anywhere you have a soil issue, this is quite possibly the solution. We did the 555 system all by itself without the soil stabilization in Saskatchewan. They were so pleased with the results, they painted lines on there.
Yeah, Scott, another really great thing to point out is the recycled content of concrete or asphalt instead of just granular applications. If you're bidding a job that has demo on it, tear that concrete or asphalt out, but stockpile it. We can repurpose it, reduce our carbon footprint, put in roads, secondary roads, lay down areas in your projects, trailer areas for your projects without you having to spend a penny to haul that material off.
And look right here, somebody stepped on the gas pedal hard and didn't ravel up any gravel out of it. And we've been back to examine this road, very positive results. So
Yeah,
site
Scott.
stabilization is a possibility, something we run into all the time. Mining roads might be something to consider. Wind farms, particularly for keeping the dust, the solar farms for keeping the dust off the solar arrays. Railroad bed soil stabilization, of course.
Yeah, Scott. Also, shoulder stabilization for your highway applications. A huge cost savings for the solar farms just by utilizing the 555. The maintenance costs go way down because you're not having to have crews go out and clean those solar panels.
It's a great program. Please contact us at SPG Go Green. Thank you very much for your time and have a fantastic day.
Yeah, Scott, we really enjoyed putting this together. Thank you all very much for taking the time to listen to us. Give us a call so we can start talking about working on your next environmentally friendly project.